going to do for starters here is we're going to take what's inside the parentheses. We're going to let u equal the expression inside the parentheses. So over here, I'm defining this new variable u. U equals 5 plus 2x cubed. Now, once you introduce a new variable, you need to set up a new antiderivative problem. So I set up my integral over here. What I've just introduced is this variable u. The reason I introduced that variable u is because it's inside the parentheses here, and that was raised to a power of 5. All right, so now we want to replace the x squared and the dx somehow. So what we do is we go back to our new defined variable here of u, and we take the derivative of that equation. So when I take the derivative of u over here, I get 1, but I get 1 du because I took the derivative of u. That equals, keep in mind again, we're taking the derivative here. 5 is going to go to 0. You've got 2x cubed, so 6x squared when I take the derivative. You just took the derivative of something that has an x in it, so we're going to attach a dx. Now, looking at what I need to replace up here, I need to replace a combination of x squared and dx. So notice, I have that combination right here. So, to replace the x squared dx, if I take this 6 and divide it over, well, dividing it over, I'd have du over 6, or I could say 1/6 du. That equals x squared dx. And since 1/6 du equals x squared dx, I can now substitute in the 1/6 du over here, since it takes the place of the x squared and the dx. Now all of these original expressions within the original problem have been accounted for. We've set up a new problem to take the antiderivative of that just has one variable throughout. If I do a little bit of housekeeping here, might make more sense to put this 1/6 in front of the u to the 5th. Keep that du at the end. Because now, if I take the antiderivative, I'm taking the antiderivative of that expression 1/6 u to the 5th. Following my limited rules here for taking antiderivatives, I add 1 to the power, get u to the 6th. I take the reciprocal of that 6, which is 1/6, and I multiply to that 1/6 in front. Get 1/36. That's as far as I can go with rules for antiderivatives, right? So now add on my c, and it would appear that we're done. The only problem is that we've concluded with a variable that we didn't start with. So I have to go back now and resubstitute for u. U is the 5 plus 2x cubed, so that's going to be raised to the 6th power. And there's my antiderivative. Yeah, because we just have the one trig function within the problem we're taking the antiderivative of, u is going to equal this piece here that follows or is plugged into the trig function. Now, as we introduce a new variable, again, we want to set up a new problem. The reason we're letting u equal x squared is because it's part of this cosine function right here. So in my new problem, I'm going to write cosine of u. I need to replace still this x and this dx in this new problem I'm forming. So now this is where I take the derivative of my equation for u right here. So derivative of u, 1 du equal to derivative of x squared, 2x dx. Combination I'm trying to replace, x dx. There's my x and my dx. So divide this 2 over, make it 1/2 du equal to x dx. So to take the x and the dx out, I have to replace it with a 1/2 du over here. Now everything's accounted for from the original problem. My new problem, I've just got one variable throughout. So if I do a little housekeeping again, maybe shift this 1/2 to the front of the cosine, I'm ready to take the antiderivative. So, taking the antiderivative of a trig function, you got this value in front of 1/2 that's just coming along for the ride. And you're asking yourself, what's the antiderivative of the cosine of u? Well, we know cosine and sine go together, right? So is it sine of u? Is it negative sine of u? Well, check yourself here. Take the derivative of the sine of u. Going back here, we get the cosine of u, so we know that's correct. Now add on your constant. Everything's in terms of u at this point. The original problem was in terms of x. So take the u out. Replace it with what it equals in terms of x. That was x squared. And you've got your antiderivative. Okay, so yeah, using strategies that we've already talked about for taking derivatives, antiderivatives. We do a little housekeeping to start. Change over some roots. Bump some things up to create the negative exponents. All right, by doing this, if I'm trying to figure out what u is going to equal now, I have the one trig function, so sine of x to the 1/2. That x to the 1/2 is the part that's plugged into that trig function. That's what I want to let u equal. You introduce a new variable, you set up a new problem. So that u replaces this part right here. It was part of the sine function, so I write sine of u. We need to adjust for the x to the negative 1/2 and the dx. So we now turn our attention to this equation for u. We take the derivative. Derivative of u now we've seen is du. That equals, you've got 1/2 x to the negative 1/2 over here, dx, because you're taking the derivative of x. What are we trying to replace? We're trying to replace x to the negative 1/2 and dx. See that combination right here. So I get rid of this 1/2 by, well, I could divide it over, but basically multiply both sides by 2, right? If you multiply both sides by 2, you've got 2 du equals x, negative 1/2 dx. I can now take out the x to the negative 1/2 and dx and replace that with 2 du. If I shuffle that 2 to the front of the sign, we're now in a position to take the antiderivative. So 2 in front of the trig function, coming along for the ride. Taking the antiderivative of the sine of u, we know that goes with cosine. The question is it positive? Is it negative? Which one is it? It's negative. Right? Because if you take the derivative of negative cosine of u, knowing the derivative of cosine of u is negative, the negatives cancel out to take you right back up here to the sun. Add on the c, and now go back and make sure that you have replaced the variable u back in terms of the variable we started with, which was x. So you got negative 2 cosine of, we could say x to the 1/2 or square root of x plus c. So to get started, adjust for your root, make it a rational exponent. Since you got a denominator, bump that up. What are we going to let u equal? Okay, we're going to let u equal t plus 3. So introducing the new variable, we're setting up a new problem. All right, the u replaces what we have inside parentheses right here. What we have inside parentheses right there was raised to the negative 1/2, so I write u to the negative 1/2. We need to take out a t and a dt. So taking my derivative of my equation I formed over here, we know the derivative of u is 1 du. We know the derivative of t is 1 dt, and that 3 is just going to 0. So looking at what I have here now with this equation and what I need to replace, I can only replace the dt, right? I can replace that with a du. Now I'm leaving myself a little space here because I need to replace this guy still. Any thoughts on how I might be able to replace t so it's in terms of u? So how about we go back here? What if you took that equation and you solved it for t? Solving this equation for t, I'd subtract 3 over, and t would equal u minus 3. If t is what I'm trying to replace right here, I know it could equal u minus 3 based on, the equation up here. Well, let's plug in u minus 3 over here, and now everything's accounted for. But we still have this product, but is this something we can multiply out? Yeah, we could distribute here. If we distribute the u to the negative 1/2 through to this u to the first, adding our exponents, we've got u to the 1/2 for that first term. And if we take that u to the negative 1/2, multiply that 3, well, you just have u to the negative 1/2. We still have the du. So basically what we're taking the antiderivative of is right here, that expression. So taking the antiderivative, going through term by term, starting with the u to the 1/2, we add 1 to that power. Adding 1 to 1/2, we get 3/2. We take that reciprocal, which is 2/3, we move that to the front. We're subtracting. For this next term, we're adding 1 to that power of negative 1/2, so we're getting 1/2 back. We're taking that reciprocal of 1/2, which is 2, multiplying to the 3 that's originally in front here, getting 6 back. And now we just add on c. We've taken our antiderivative, we've done so in terms of u. Got to go back to the original variable, which was in terms of t, and basically substitute back in. So substituting back in for u is t plus 3. We've got 2/3 times the quantity t plus 3 to the 3/2 minus 6 times the quantity t plus 3 to the 1/2 plus c.